Hey guys, so we're going to be working on the last set of notes for Chapter 5, which is 5.6, and we're going to be now changing from just graphing inequalities to graphing linear inequalities. So what's that going to look like? How are those open circle, closed circles going to work when I'm drawing a line, right? How's right or left going to work if I'm drawing a line? So we're going to have to change our language a little bit with the linear inequalities. Okay, so we're going to talk about graphing the linear inequalities, and we're going to talk about some steps. We're going to talk about what's going to be happening, and then we're going to do some practice. So here we go. So here's our procedure. So step 1, we're going to solve the inequality into slope-intercept form. Okay, so remember, that one has an equal sign, right? Y equals mx plus b. So the only thing that's going to be different is that we won't have an equal sign. It'll be some sort of inequality, okay? So in that basic form where y is alone, the x term is after the inequality symbol, and then the y-intercept is after that. Okay, next, we're going to identify the slope and the y-intercept. Okay. Now, these are the two things we're going to use to graph. Graph using these two values. So we'll graph the point, and then the slope will take us to a location of another point on the line. Okay, now this is where it gets interesting. So remember how we had open circle, closed circle? So the open circle means the answers aren't a solution, okay? And remember that went with greater than or less than. So for us, what we're going to do is we're going to graph a dashed line. And I'm going to surround my dashed line with dashes. So that means that nothing on the line is a solution, okay? And then the other guy was the closed. So that one, when the inequality is greater than or equal to or less than or equal to, so that's going to be a solid line because every point is a solution that's on that line, okay? Now, how do we deal with the shading right or shading left? Well, this is how we're going to look at it. We're going to shade above. That's going to be the same as kind of our right. And that's when we have greater than or equal to. And then we're going to shade below, and what I'm referencing to above and below obviously is the line. So that would be what we were referring to before on the number line is left, and that would be less than or equal to. Okay. Now, the single most common mistake made on these is getting the shading in the wrong spot. So we're going to test a point the shaded region, at least what we think is going to be the shaded region, to verify it is correct. Because getting the shading right is the single biggest mistake, okay? So let's do an example. No, let's do an example, and then we're going to write some more stuff. So a quick example would be, let's say we have this set of directions. Graph 2x minus 3y is less than 12. So now, some of you might say, well, wait a second. Can't on this one just figure out the x-intercept and the y-intercept? And the answer is, well, yeah, you could do that, but here's the problem. Bam! You don't know how to shade because you don't know what the inequality is going to be. That's why it has to go into slope-intercept form, is so that we know what the final inequality looks like. So that's the whole gist on that sucker. So we're going to go ahead and subtract 2x from both sides. That's going to give me negative 3y is less than negative 2x plus 12. And then we're going to divide everything by negative 3. Okay. And that's going to give us, ooh, look at that. Divided by a negative. That's going to give us y is greater than, two negatives make a positive, 2/3 x, one negative makes a negative 4. Okay, so my key information, the slope is 2/3, the y-intercept is negative 4, and then the inequality tells me this, dashed line, and we're going to shade above. Okay, so I'm going to go ahead and get my little plane up. Let's see, we go -4. And I always kind of do my equations, or my coordinate planes, kind of to go along with what I'm graphing. Don't forget to number your tick marks, count by reasonable intervals, and then I'm going to go ahead and graph. So we go to where y equals negative 4, then we're going to rise up 2 and to the right 3. That should take me to the point 3, negative 2. Now we're going to draw a dashed line through those numbers, or through those points. So you might want to use a colored pencil to help you with this part. Now, I'm going to test. So I'm going to tell you what I like to test. I want to test the simplest numbers possible. So I often test 0, 0. Now, my thought is I'm going to be shading above. So if I put in 0, 0 to the original equation, will I get something that's true? If I get something that's true, then that means I need to shade where 0, 0 is. So I get 0 is less than 12. Okay, that's true. So that says you're going to shade above. And this is how we can shade. You can shade with the side of your pencil. You can shade with a little mark like that. You can shade with color, whatever you want to do. Okay, I'm going to go to the other side, and we're going to write some more. I know, you're like, fabulous, thanks so much. Okay, so we're going to kind of reiterate this. That was just a little bit of information. Graph of a linear inequality. You might say you're being repetitive. Yeah, that's okay. If me going through this twice gets it into your brain, I have done my job. Because it is very important. Now, the line we're drawing gets a special name. It's called a boundary line. So the boundary line is the one we graph. So it's graphed from slope-intercept form. So I'm going to fill in some of the data from before, okay? And this boundary line can be either dashed or solid. And again, we talked about how it's dashed would be greater than or less than, and solid would be greater than or equal to or less than or equal to. Okay? Now, the other thing I didn't give a word to was, what do we call the shaded part? Okay? It's called a half plane. So that is where we do the shading. Okay? So it's the infinite solutions for the linear inequality. Now, by solutions, we're talking ordered pairs, right? Because it's points. And you might say, well, how can they be infinite? Because it's only one quadrant or one section, one half of a graph. Well, remember, it's going on forever off the paper. Okay, so we have a starting point, that's the boundary line. That tells you where the solution begins. But then the half plane, the shading, is going to be all the other points. So remember, we gave, if we have greater than or greater than or equal to, we're going to shade above the boundary line. Okay, and if we have less than or equal, we're going to shade below the boundary line. Now, let's see. What if you're going to do a vertical line? Vertical line doesn't really have an above or below. So I'm going to put that in here. So if boundary line is a vertical line, you're going to shade right, and that would be for greater than, well, we'll do that, or greater than or equal to, just like we would do on a number line, or left, and that would be if we had less than or equal to. Okay, so that's something interesting. And again, we're going to test a point. And let me tell you, you want to do this before you shade, because if you shade and then you test a point and you realize you did it wrong, you're going to have to erase all the shading and probably have to draw some of your line back. So that's why you always want to shade. Okay, now test a point to verify the correct shading. Okay, now here's something to pay attention to. You cannot test a point that is on the boundary line. It has to either be above it or below it. Because kind of like getting a false positive. Okay, so we have two things that could happen. we can get a true statement, like we did in the example I did on the other screen. So again, a true statement, you're going to shade the half plane that contains the point, or contains that point. So you pick a point, stick it back into the equation, the original one. I'd always go back to the original one. And then if it comes out to be true, then it says where that point is, you're going to shade, right? Now, if you get a false statement, then that means you're going to shade the half plane. That does not contain that point. So, kind of how I look at this is, since it's so easy to calculate with 0, 0, is as long as it's not on the boundary line, that's the point that I tend to choose. And if I get a true statement, that means I'm going to color over where, or shade over where 0, 0 is. If I get a false statement, I have to shade the part of the boundary line that has nothing to do with 0, 0. So I kind of just use 0, 0. And if 0, 0 is on my boundary line, then I try like a 1, 0, or 0, 1, or a 1, 1. You know, the smaller the numbers, the easier the calculation. Okay? So again, I'm going to add that statement I just made. Always test a point in the original inequality. Now, the reason why I say that is because what if you made a calculation error? What if you made a sign error? You wouldn't catch it if you substituted your point into the slope-intercept form. So if you go back to the original form, then maybe you'll catch your error, because you might be thinking, oh, it should be here, but then it doesn't work out that way. So again, let's talk about points to try. So I love 0, 0. 1, 1. 0, 1. 1, 0, those are all my kind of favorites, but again, that's kind of the order. And then you always can choose a point you believe will be in the shaded region. The half plane, right? Okay. So again, I think we may have got this down, but I'm just going to add it in. Every point in the shaded region, or in that half plane, is a solution to that inequality. Okay, so that's important. All right, 2 examples and we're done. Two more, I should say. So directions say graph the solution. And just when you think this might be, oh, good, I only have to do this for a little while, we're done. We're going to talk about a system of linear inequalities where you got 2 inequalities graphed on the same axes and have to figure out what the solution is between those 2. But that's chapter 6 at the end. Okay, so we get x plus 5y is less than or equal to 10. So again, I have to first start putting it into slope-intercept form. I subtract x from both sides, and I get 5y is less than or equal to negative x plus 10. So again, some of you guys, I noticed, were doing your solution so that the variable would come after the inequality. Please stop. Just trust me on this. Dividing by a positive 5, that's not going to change the inequality. I get y is less than or equal to. Now I'm going to pull out the coefficient that's with the x, and we're going to pull out the slope, which is negative 1/5. And then over here, 10 divided by 5 is 2. Okay, so my key players are going to be, the slope is negative 1/5, and the y-intercept is 2. Another key player, less than or equal to, means I'm going to have a solid line, and I'm going to shade below. Okay, so those are my estimates of what my graph should look like. So I'm going to go ahead and get my axes in. X marked, Y marked, 2, 3, 4, 5, 2, 3, 4, 3, 4. That should be good. Okay, so we're going to start where the y-intercept is 2. Then we're going to rise down 1 and to the right 5. So it should take me to the point 5,1. Now, it's a solid line, so I'm going to go ahead and do that. Now I got to figure out what's my half plane. So I'm going to test. Now let's see, below would cover over 0, 0. So I think when I substitute in 0, 0, I should get a true statement. So let's see if that holds true. So let's see, we get 0 plus 5 times 0 is less than or equal to 10, and we get 0 is less than or equal to 10. Since that's true, that tells me I'm going to make sure I shade over 0, 0. Okay, so, and you could shade with a highlighter too. Let's do that. So we're going to shade over 0, 0. Okay, and you can test any point in that area, and it should come out to a true statement, and vice versa. I can choose any value above the line, and it should give me a false statement. And it looks like I got a little aggressive with my highlighter marking. Sorry about that. Let's get that green back in there. That looks like it's a dashed line now, right? Now it just looks like a squiggly line. Okay. Yeah, I think on second thought, I might not use the highlighter. It's messy for me. But if you're using an actual one, it shouldn't be. All right, so let's do this one. 3x plus 5 is less than 14. So you're like, first off, you're like, are you sure this is not just a number line problem? Because I only see one variable. But this is going to be on a whole page about linear inequalities, so it's a line. So we're going to subtract 5 from both sides. Sorry, I heard a weird sound. I think it's my cat, but hoping it's my cat. We get a 9 divide. Oops, sorry. Red for work. Divide by 3, because I get mad if I don't see it. Arr. I get x is less than 3. Okay, so this is the scenario we talked about. All right, so let's identify slope and y-intercept. This one's a little bit interesting. I forgot what color I was using. Here we go. Okay, so slope, if it's just an x, it means it's undefined. Okay, and what's the y-intercept? None. It's the point behind vertical lines. They don't interact other than if it's y is less than 0. Okay, now let's look at the inequality. Sorry, that color. So we have a less than. So let's see, that's going to be dashed. Now, we would normally think the word below, but because it's a vertical line, we're going to use the word left, okay? Because that makes more sense in this. So we're going to get a vertical line. At where x equals 3, okay? So I'm going to go ahead and get my coordinate plane together. And honestly, all I need to do is put numbers here. Now, I am going to do a dashed line passing through where x equals 3. Got to have arrow caps on there because it's going forever. So I'm going to do my test, and my test is going to be 0, 0, which is, in this particular case, should be giving me a true statement. So let's see what happens. So I go back to the original. 3 times 0 plus 5 is that less than 14. And I get 5 is less than 14. That's true. So that says, yep, you're going to shade where 0, 0 is. So I'm going to be less aggressive with my shading this time. And I'm going to just, ooh, I didn't mean to do that. I chose just a different color of shading. So I'm shading from my dashed line to the left, crossing through 0, 0. And there you guys go. Have fun with this. Bye now.